So now I will pass it over to Wendy Reed from the Nuclear Regulatory Commission. Thanks for joining us this morning, Wendy.
Thank you very much, Lauren. Before I start sharing my slides, just want to make sure, can everyone hear me okay? Great. Just a little bit about myself. I'm one of the technical leads for advanced reactors in the Division of Engineering in the Office of Nuclear Regulatory Research. My particular focus is on chemistry and corrosion. I have a background in chemistry. And secondly, I'm just a bit of housekeeping. I'm going to turn my camera off when I share my slides. I'm like Jean. Yesterday, I'm sharing bandwidth with a couple of young co-workers, so I just want to make sure we're preserving the connection. So I'll put the camera back on for Q&A, so I will see you shortly. Okay, sure. Okay, can everyone see my slides okay?
Yes.
Yes.
Great, thank you. So I'm very pleased to be here today to provide an overview of NRC's activities to prepare for the potential licensing of advanced reactors. So this is just a snapshot of what I'm planning on talking about today. What I'd really like you to get from this presentation is just a feel for the numerous activities that NRC is involved in to better ready itself for the potential review of advanced reactor applications. And I should add here that the NRC considers itself ready now to review advanced reactor applications. This is evidenced, by the recent acceptance of the Oklo microreactor application, which is currently under review. What these activities that we're involved in are really doing are going to improve the effectiveness and the efficiency with which we conduct our reviews. So I understand that we have people from all over the world joining today, so I realize that not everyone may be familiar with the NRC, so I wanted to include this slide to give a quick overview of what the NRC is and what it does. It is an independent agency that began operations back in 1975, having been set up by Congress the year previous. And the mission of the NRC really is to help ensure the safe use of civilian radioactive materials while protecting people and the environment. And we regulate commercial nuclear power plants and other uses of nuclear materials, such as nuclear medicine, through licensing, inspection, and enforcing of our requirements. Now, as I'm in the Office of Nuclear Regulatory Research, it was a congressionally mandated office, and it supports the NRC in all the areas of work that's involved with, including developing and maintaining computer codes, and also leading the agency initiative for cooperative research. So before I get into NRC's activities related to advanced reactors, I did want to show this slide because I think it really illustrates brilliantly the wide range of advanced reactor designs that are under development. And as you can see, it really is a large and diverse landscape, particularly with the molten salt reactor group. And so therefore, the NRC has really made sure to focus on technology inclusive strategies to benefit a wide range of technologies as it goes forward. Bit of history for you all. So back in 2016, to prepare for the growing interest in advanced reactor designs, the NRC issued its vision and strategy document back in December of that year with the goal of enhancing NRC's readiness to review and regulate non-light water reactors. And then in July of 2017, to support the goal of more efficient and effective licensing strategies, the NRC issued its Implementation Action Plans, or IAPs, which define near-term, mid-term, and long-term activities. And this slide shows the near-term activities that are currently ongoing, and you can see there's a great variety of activities the NRC is involvement with the ASME codes. We've held so many stakeholder meetings and public meetings relating to this, and it really has been a huge effort with all the offices in the agency, led by the Office of Nuclear Reactor Regulation. And so these efforts are underway in each strategy, and the check marks show the things that have actually been completed today. I would like to draw your attention to the strategy one, the molten salt reactor training. That was an excellent workshop that Oak Ridge put on primarily for the NRC staff. However, if you Google, I tried this morning, molten salt, NRC molten salt class, you'll be able to get access to the training materials, and it really is an excellent resource. So I would like to take this opportunity today to actually highlight some of the work that I'm specifically involved with. The strategy 2 of the IAP, the computer codes and review tools. It also involves getting ready to evaluate the safety and potential materials engineering challenges associated with the new materials and components that may be used in advanced reactors. And over the past several years, significant work has been conducted to work towards the objectives that are listed here on the slide. In the case of molten salt reactors, the NRC, Specific Office of Research in this area, has developed a great working relationship with Oak Ridge National Lab to help us build that expertise in molten salt reactors and identify challenges associated with molten salt chemistry and salt compatibility, things like that. And that work is going on. So if you'd like to learn a bit more about some of the work in the materials and in component integrity research area, this slide here provides some references, including the technical gap assessment that Oak Ridge did for us regarding materials and component integrity for MSRs. And the numbers there are the NRC document numbers. So I'd like to move away from the research now and talk a little bit about some of the regulatory and licensing aspects of NRC's preparations. And one of NRC's key accomplishments has been the publication of Regulatory Guide 1.233. I'm going to apologize here because in the references, which is at the end of my presentation, I didn't update it, so it still shows the draft right guide. So that's my 1253. So that's my first apology on this slide. And this document endorses an industry-led licensing modernization project, or the LMP, and it's described in NEI document 18-04. So I'm not going to discuss the LMP in great detail, but I think this diagram does a great job of capturing the essence of the LMP. An advanced reactor design would be put through the prism of LMP, as it were, which allows the applicant to use a technology-inclusive, risk-informed, and performance-based methodology for selecting licensing basis events. And my second apology for this slide with all the acronyms. So you have your design basis accident, your anticipated operational occurrence, design basis events, and beyond design basis events. And what that will help you do is to classify your structure systems and components depending on their safety significance. And so ultimately, what you want is to focus most of the effort and your energy on really reviewing those most safety significant aspects. Another thing I want to discuss today is Part 53. So a little bit of history. In January 2019, the Nuclear Energy Innovation and Modernization Act, or NEMA, was passed into law and requires that the NRC complete a rulemaking to establish a new technology inclusive, risk-informed and performance-based regulatory framework for advanced reactors by the end of 2027. And as you can see on this slide, the staff recently received its requirements memorandum from the Commission, and the Commission is looking for us to accelerate this timeline considerably and have instructed staff to issue the final rule by October 2024. And the NRC is committed to having extensive stakeholder engagement on this rulemaking. The first public meeting was held last month. I wasn't in attendance, but I understand it was a very productive meeting. And I know there will be many more opportunities for engagement with the NRC about this rulemaking going forward. So I think it was Christine said yesterday, it really takes a village. And I think particularly for molten salt reactors, there's such a new paradigm compared to what the types of reactors that the NRC has licensed in the past. And I hope that, you know, through my presentation as well, you have an appreciation how NRC does recognize the importance of collaboration and cooperation to enhance our ability to conduct our mission. We've have MOU with DOE, including in the area of molten salt reactors. We've got a very active cooperative effort to coordinate the research activities and information sharing between the two agencies. We've also, NRC, I'm sorry, has also signed a memorandum of cooperation with the Canadian nuclear regulator to better share best practices and information regarding the licensing of advanced reactors, including molten salt reactors. And one of the things I'm particularly excited about at the NRC at the moment is the NRAN program, which is the Nuclear Reactor Apprentice Network, where the NRC hired a cohort of new graduates to the agency. I'm very excited because my branch is going to have one of these apprentices working for us for the next 6 months, during which time he's going to get immersed into molten salt reactor chemistry and look at its impact on materials performance and really help build up the staff expertise in molten salt reactor related issues. And so before I conclude, I just want to give a plug for the research information letter that was recently issued, summarizing several important sessions that were held as part of the Advanced Reactor Workshop in Materials and Component Integrity. There was lots of great sessions during the workshop, including a couple of molten salt reactor related topics, on graphite and molten salt chemistry. The workshop was great, and I think it really was a great example of, as I think it was Alice referred to yesterday, is the vibrant community that exists around advanced reactors. So in summary, the NRC continues to work to complete its implementation action plans, and we'll be working hard to finalize the Part 53 rulemaking by October 2024. And finally, I think communication and cooperation is really key now and going forward for effective and efficient licensing of molten salt reactor technologies. And if you can just indulge me a little bit longer, I did include a few background slides for your information. So this gives you a link to the NRC's Advanced Reactor public webpage, which has a plethora of information about NRC's activities, including a schedule for the different activities it's involved in. And this is some of the reports contractor reports that have been prepared, including one on the fuel salt qualification methodology and and tritium. And then there's a list of references. So thank you for your time.
Thank you, Wendy.
You're welcome.
Greg, can you confirm that no questions showed up in the Q&A?
Yes, there was only the one I sent you.
Okay, great. Thank you so much. I appreciate that. Wendy, I really appreciate you giving us the update. NRC is obviously really leading in this way, and we appreciate the industry collaboration. I know one of the things that you mentioned was continuing to grow that expertise on MSRs. And I think we've already found a few ways to work with you guys on that. But if there are additional ways that we can help educate or provide our information that we've, been working on, please let us know how we can best engage with you guys.
Hey, Lauren, we just had a question come in.
Lauren.
Fantastic.
The question is the NRC still hiring into the new grad program?
I'm afraid I don't know about that. I think, but let me try and find out for you, and I will today, and I will get back to you on that.
Thanks, Wendy, and thanks, Greg, for reading that out for us. We'll see if any other questions come in the Q&A while we move on to the next presentation, if that's good, Wendy.
Yes,
Thank you.